Okay, class. Today we're going to be doing characteristics of linear functions. Now, keep in mind there's a whole lot of notes today, so a lot of the time you're going to spend pausing the video and taking down notes. So let's talk about parent functions. We know that the parent function, the formula is y equals x. So remember, that's the parent function we're going to focus on most of the time, y equals x. And so we know, because we looked at our remembering your parent sheet, that the domain for these are all real numbers and that the range for this is all real numbers as well. And we know that for everything that your x is, because y equals x, that your y will be also. Now, what patterns do you observe? Just what we said. For each point, the x value, the y values are equal. And as x increases, y increases. And that you can have fractions. If you notice on our table, we do have a 3.5 and a 4.5, so that is a fraction that is possible as well. Now we're going to review the characteristics. There's three different forms you're going to get used to seeing these linear function in. That's going to be standard, point slope, and slope intercept. I want you to familiarize yourself with all three of these. Make sure you know all of these. And make sure that you understand that for the standard form, you cannot have a fraction and your a cannot be negative. It has to be a positive value. And we're going to go over these a lot more too in class. So I know that in the slope intercept form that I want to recognize how my slope changes and how my b intercepts. So take a moment and I want you to write down what's at the bottom. So now's a good time, once I get all this shown, to pause your video so that you can get that. Okay, so now we're on page 2. Now, how would you define your slope? I know there's many different ways that we can define this. So I want you to be familiar with it as being a line's rate of change. And I also want you to be familiar with knowing that it's a measure of how steep or how slant a line is. How steep or how slant a line is. And in order to find your slope, if I'm looking at a graph, I know that I have to count rise over run. So I'm going to count how far up it goes and how far over it goes, correct? So for this one, I notice that if I'm looking at one of my coordinates, I have to go up so many points and over so many points. Let me try that again. That's a little bit big there. So I recognize that I'm going to have to go up, rise, how many points? And then go over how many points? Okay, that's going to tell you your rise over run. So I rose 4 and then I ran 2, and we know that 4 over 2 is going to give me a slope of 2. So what if I have that data in a table? Well, if I have it in a table, I'm going to look at my change in y over my change in x. Now you see this little symbol you see down here? Let me highlight it for you. This little symbol here, that's called delta. Delta y, delta x. That means the change in y and the change in x. So if I'm looking at that, I know that my change in y, I'm going from 5 to 19. So I would ask myself, what am I changing from? And then I'm going from 2 to 4. So to go from 5 and 19, I'm changing 14, right? And then going from 2 to 4, I'm changing 2. And then 14 over 2 would give me what? It would give me a slope of 7, correct? Now, what if I have 2 points? How do I find my slope if I have 2 points? This is the way you're most familiar with. You're used to having y2 minus y1 over x2 minus x1, which is what we're doing here. So here I'm going to have a slope of negative 8 over 5. What if I have an equation? If I have an equation, I know I need to get it to look like what? Y equals mx plus b. So if I get that to looking like y equals mx plus b, It's now in slope-intercept form, and it'll be easy for me to see what my slope is. So on this first one, I can see that my slope's a -2. On the second one, I can easily see that my slope's a 2/3 because it's whatever with my x, no matter where they put the x. But what would I have to do first on that third one? Correct. I would have to take my 3x to the other side, and when 3x goes to the other side, it becomes negative. Therefore, my slope there would be a -3. So now let's talk about intercepts. Intercept is our b, so we're going to focus on finding our b now. So as I was saying, we're going to focus on our b. Now, the intercept is the point where a line crosses the x or y axis, and more often than not, we focus on the y axis. So it's a point where a line intersects or crosses the x or y axis. So we want to explain how to find a y-intercept from each representation. So if I'm looking at a graph, I'm going to look at where it crosses what? Correct, the y-axis. If I'm looking at a table, I'm going to look for the point where what is 0? And my y-intercept, what will be 0? That would be correct, my x. If I'm looking at the equation, it's going to be my b value. And if I'm looking at any equation, can I plug in x for 0 and then solve for my y? Plug in x for 0 and solve for the y. Yeah, I've gotten pretty good at coming up with that. Now, what if I want to find the x-intercept? Think about it. It's going to be where the line crosses what? That's correct, the x-axis. What about from a table? What's going to be 0? That would be correct. That would be my y. And if I'm going to plug it in, I'm just going to plug in 0 for y. And then solve for my x value. Good job. Okay, now we're on page 3, and we're going to look at characteristics of a linear function. There are several ways to determine the equation of a line depending on what they give you. So if you have the slope and y-intercept, I simply need to use the slope-intercept form and plug it in, correct? Plug in my m and my b. What if they give me the slope and then coordinates, which is an x and y? If they give me slopes and the coordinates for a point, that's a point and slope. So in that case, I'm going to use my point-slope form. And what if they give me 2 points? Well, if I have 2 points, I know I can find my slope. And then after finding my slope, I can use the point-slope form and then find the equation. What if they give me a table of data? Well, then I know I can go to statistics in my calculator and create a line of regression, and we'll work on that in class. So let's talk about the different kind of slopes for special lines. If I have a horizontal which lays down, I know that my slope is going to be 0. And what will an equation look like? It's going to be y equals some number. If I have a vertical line which goes up and down or north and south, I know I'm going to have an undefined slope. I can't ski on a line going straight up and down, but I can ski on a horizontal. I'm just skiing at an altitude of 0. Excuse me. And that equation is going to look back like x equals some number. What if I have parallel lines? What do I know about parallel lines? That's correct. My slopes are parallel. If my lines are parallel, my slopes are equal. So it'd be something like y equals 2x plus 3 and y equals 2x plus 7. That would be an example of that. What about perpendicular? Well, slopes of perpendicular lines are going to have the opposite reciprocal or the negative reciprocal. So for instance, if one line is y equals 2x plus 3, the other one would look like y equals -1/2x minus 7. Remember, the emphasis is not on the 7 and 3, it's on the 2 and then the -1/2. So now we have some sample problems. So using those points, which remember, those points I just got from looking at the line, I want you to determine the slope. Now we can use rise over run. What would you get here? Okay, I should have got a 2 because I would have to rise up 2 and over 1 to get my slope. And then you can very well see here, and we'll work on this a lot more in class, but you can easily see where is it crossing the y-intercept at -5, which gives me the negative 5 value. And I got to go up 2 over 1, and that's what's giving me my slope of 2. Okay, this is the same type of problem, and it wants us to do it again. They're giving us the 4 points. So I'm going to graph the function, and then I want to determine the slope. So I'm going to carefully look and see how far I got to rise and how much I have to run. So that would be 1, 2, 3, 4, 5, 6 rise and run 2 in the negative direction. So 6 over negative 2 would give me what? That's correct, the slope of a negative 3. So how would I find the equation? I already know my slope. I need to know my b, right? And my b is where it crosses. My b is where it crosses. Where does it cross my y-intercept? It's correct. It crosses it at 7. So my formula becomes negative 3x plus 7. Now I want to know what the intercepts are. So I would have to, I already know my y-intercept is 0, 7, right? How would I find my x-intercept? I would just plug in 0 for y and solve the equation and find that it's going to be 7/3. Okay, let's go to the next page. Okay, so let's take a look at this on page 5. From the given information, find the equation of the line, both in slope-intercept form and standard form. So I know that I'm going to have to use the point. Let's work over here to the right. So I'm going to have to, I already know what my slope is, but I need to, I have a point and I have a slope. So I know I'm going to have to use y minus y equals m x minus x. So I'm going to use y minus 5 equals m. My slope is negative 1/2, and then x minus a negative 2. Sorry, I'm having pen trouble here. Let me try to make it work. Okay, so that gives me y minus 5 equals, when I distribute that, I get negative 1/2 x. Now that negative made that positive. But then when I multiply by negative 1/2, it's going to make it a negative 1. Correct? So now I just got to take that 5 over. When I take that 5 over, it's a positive 5. So that's going to give me y equals negative 1/2 x plus 4. So that's my equation in slope-intercept form, correct? Now I need it in standard. And remember what we said for standard. I can't have a fraction and my leading coefficient cannot be negative. So in order to get rid of that fraction, I know I got to multiply everything by 2. So that gives me a 2y equals negative x plus 8, correct? Now I got to have it look like ax plus by equals c. So my x has to come over. And when that x comes over, it's going to be positive x plus 2y equals 8. So this is what you should have gotten there. Now I want you to take a moment and watch a couple more videos, and we'll finish this up in class. Or not watch a couple more videos, work a couple more problems. Hope you had a good evening, Miss B. See you tomorrow. Bye-bye.